Let's take a look at adding and subtracting fractions. And I'm going to give you a step-by-step approach on this. So we're going to have add or subtract fractions. Now step 1. Get a common denominator. So get a common denominator. Now that step isn't as simple as it just sounds, but we'll talk about that. And then step 2, add or subtract the top parts numerators and put into a single fraction. Step 3, simplify the fraction. Okay, let's look at these steps. Look at our first problem here. We got 3/7 minus a negative 11/7. This uses one of our shortcuts we looked at. Remember, a negative parentheses negative becomes a positive. So this becomes 3/7 plus 11/7. Wherever you can use that shortcut, you go ahead and do it before you do anything else. Okay, step 1. Get a common denominator. These already have a common denominator, so we don't have to do step 1. Step 2. Add or subtract the top parts. 3 plus 11 gives us 14. And then our denominator remains 7. So we put it into a single fraction. Well, step 3. 14 divided by 7 is 2. So 2 would be our answer. Okay, let's look at this one. We got 2 minus 2/5. As always, if we add, subtract, multiply, or divide fractions, we want them both to be fractions. So I'll put the 2 over 1 minus 2 over 5. Okay, step 1. We want to get a common denominator. Now, whenever you have a denominator that's a 1, then your common denominator will always be the other one. So 5 is our common denominator. And this one already has a 5, so I'll leave it alone. Now our first fraction here, you have to think, what did you multiply by your old denominator to get your new one? Well, we multiplied the old denominator by 5. So whatever you multiply by the bottom, you have to multiply by the top. So we'll multiply the top part by 5. And 2 times 5 is 10, so we got 10/5 minus 2/5. Step 2. Add or subtract top parts. They got the same denominator now, so 10 minus 2 is 8, and then that denominator stays 5. Now we don't need to do step 3 because this fraction is simplified as much as it can be, so 8/5 is our answer. Now I'm showing this way because this works 100% of the time. If you're going to go into certain fields like nursing, you should probably know how to work this. Another way to work this is considered a mixed number. Mixed number format is where you have an integer of some sort and then a fraction. Now, to do this with a shortcut for mixed numbers, you take the integer out in front, the number out in front, you multiply it times your denominator. 2 times 5 is 10, and then you add the number up on top, which is negative 2. So 2 times 5 is 10, plus a negative 2 gives you 8. And then your denominator stays as is. One important note on this is when you have negatives involved, that negative always has to go up with a 2. It would never go down here with a 5. So again, a negative should go up with the numerator, not the denominator. And if that throws you, again, just follow our steps here. They'll always work. Okay, let's look at our third example. Got negative 1/4 plus negative 5/18. Well, I can apply one of my shortcuts to begin with. Positive parentheses negative becomes a negative. Okay, so now we're ready to go through our 3 steps. First step is get a common denominator. Well, let's take a look at how to find the LCM of 4 and 18. If you remember finding the prime factorization of these, our first step in finding the LCM is we need to write down a prime factorization of each number. Well, if I look at 4, if I did my tree, 4 is 2 times 2. 2's prime, so we circle it. 2's prime, so we circle it. So 4 is 2 times 2. If we look at 18, we start with our first prime, which is 2. It is divisible by 2. 2 times 9. 2's prime, so we circle it. Now we're going on. The 9, we're still on the 2. It's not divisible by 2, so we go to our next prime, which is 3. And it is divisible by 3. 3 times 3. So this one would be 2 times 3 times 3. So our LCM, we start with our first prime. So we start with 2. Now I'm looking for the greatest number of 2's on any single line. There's 2 of them here, there's 1 of them here, so greatest number of 2's on a single line is right here. There's 2 of them. Keep in mind, we're not counting how many 2's there are. We're looking for the greatest number of them on any single line. Then we go to our next prime, which is 3. There's no 3's here. There's 2 3's here. So the greatest number of 3's on any single line is 2. 2 times 2 is 4, times 9 is 36. So that would be our LCM of 4 and 18, which is actually our least common denominator. You'll find that LCM and LCD kind of serve the same purpose. They allow us to get something the same. Okay, now this one's got a negative up here. Let's look at our old denominator, the 4. You ask, what did I multiply by the 4 to get 36? We multiplied it by 9. So whatever you multiply by the bottom, you have to multiply by the top. So this will be 1 times 9. Now our second fraction here, you ask yourself, what did you multiply times 18 to get 36? And that'd be 2. So whatever you multiply by the bottom, you have to multiply by the top. So this would be 5 times 2. So that gives us negative 9 over 36 minus 5 times 2 is 10 over 36. Step 2. Add or subtract the top parts. We got negative 9 and negative 10. That gives us negative 19 over 36. Now our third step would be to simplify this fraction, but 19 looks prime, so we can't do anything with that. That would be your answer. Let's look at this problem. And number 4. We got 11/6 minus 7/4. Step 1. Get a common denominator. Well, let's take a look at the LCM of 6 and 4. And again, this will give us our common denominator. And specifically, our least common denominator. Well, step 1, do the prime factorization of each number. 6, I haven't done that over here, so 6 is 2 times 3. 2's prime, so we circle it. 3's prime, so we circle it. So 6 is 2 times 3. Now 4, I went ahead and created a tree up here. 4 is 2 times 2. So then our LCM. We start with our first prime, which is 2. And I'm looking for the greatest number of 2's on any single line. There's 1 here, there's 2 here, so greatest number of 2's on any single line is 2. Then I go to my next prime, 3. I'm looking for the greatest number of 3's on any single line. There's 1 here, none here. So the greatest number of 3's on any single line is 1. Well, 2 times 2 is 4, times 3 is 12. So the LCM of 6 and 4 would be 12. So we want to rewrite each fraction with that new denominator. Now again, you look at your old denominator and you ask, what did you multiply by to get your new one? Here we got 6, and here we got 12. We multiplied the 6 by 2. So whatever you multiply by the bottom, you have to multiply by the top. So this would be 11 times 2. In my second fraction, we had a 4, and we ended up with 12. We multiplied the bottom part by 3. So you have to multiply the top part by 3. 11 times 2 is 22. And over here, 7 times 3 is 21. Step 2. Add or subtract the top parts. 22 minus 21 is 1 over 12. Now we don't need to do step 3 because there's nothing to simplify in this fraction. That's as low as it can go, simplification-wise. Let me save this before we work the next problem. Adding, subtracting, fractions, page 01. Okay. Let's take a look at this one. We got 1/4 minus 5/12 plus 1/3. It doesn't matter that we have 3, it's still the same idea. Our first step is to get a common denominator. And I know some of you can just look at this and see it, but I'm going to show all the steps. So we're finding an LCM of 4, 12, and 3. All our denominators. Well, first step is to have the prime factorization of each one. 4 we already said was 2 times 2. Now 12, I don't think I've done a tree for that. 12, start with my first prime, which is 2. 2 times 6, 2's prime, so we circle it. Now we go on to the 6, which is 2 times 3. 2's prime, so we circle it, and 3's prime, so we circle it. So our prime factorization is 2 times 2 times 3. Now 3. 3 is just prime, so we don't do anything with it. It just carries along like that. Step 2. Figure your LCM. We start with our first prime, which is 2. And I'm looking for the greatest number of 2's on any single line. There's 2 of them here, 2 of them here, none of them here. So the greatest number of 2's on any single line is 2. Then I go to my next factor, the 3. And I'm looking for the greatest number of 3's on any single line. None here, 1 here, 1 here. So the greatest number of 3's on any single line is 1. 2 times 2 is 4, times 3 is 12. So 12 will be our common denominator. Now I want to rewrite all those fractions with that new denominator. The middle one already has 12, so I don't have to change it. Our first fraction, we multiplied the bottom part by 3, so we have to multiply the top part by 3. Over in our last fraction, we multiplied the bottom part, the denominator, by 4, so we have to multiply the top part by 4. Whatever you multiply by the bottom, you have to multiply by the top. So that gives us 3 12s minus 5 12s plus 4 12s. Now we looked at the order of operations, and I could handle these a piece at a time here. So going from left to right, I'll do these two. This is step 2. Add or subtract the top parts. Well, positive 3 and negative 5, that gives me a negative 2 over 12 plus 4 over 12. Now you don't want to get all excited and simplify this fraction because these already have the same denominator. So it would be detrimental for you to actually simplify them at this point. Now we'll do these. Negative 2 plus 4 gives us a positive 2 over 12. And finally we see step 3. Step 3 says simplify the fraction. And you think of a number that you can divide the top and bottom by, and they're both divisible by 2. So this would give us 1/6. And that would be our answer. Let's take a look at this one. We got 1/15 minus negative 1/12 plus 2/9. Well, to begin with, we got a negative here. That becomes a positive. So we got positive 1/12 plus 2/9. Step 1, get a common denominator. So let's take a look at this. We got the LCM 15, 12, and 9. And we want to do the prime factorization of each number. Now 15. 15 is 3 times 5. 12 we've already done. 12 is 2 times 2 times 3. And I think we did 9 also. 9 is 3 times 3. Our second step over there, your LCM is, we'll start with our first prime, 2. We're looking for the greatest number of 2's on any single line. There's none here, there's 2 here, there's none here. So our greatest number of 2's on any single line is 2. Now we'll go to the 3. We're looking for the greatest number of 3's on a single line. There's 1 here, 2 here. So greatest number of 3's on a single line is 2. Then we'll go to our last prime, the 5. We're looking for the greatest number of 5's on a single line. There's 1 here, none here, none here. So the greatest number of 5's is 1. Let's see. 2, 4, 12, 36 times 5. 0, 3, 180. Let me see. 15, 30, 60, 180. Yeah, 180. So we're going to rewrite each one of these fractions with that new denominator. Now these may not be so easy to see. You know, what did you multiply by 15 to get 180? And you can always do your old style division for that. 15 goes in 18 one time. 1 times 15 is 15. Subtract that, you get 30. 15 times 2 gives you your 30. So I multiplied the bottom part here by 12, so I multiplied the top part by 12. So we got 1 times 12. Now for the next fraction. What did you multiply by the 12 to get 180? Well, 12 goes into 18 one time. That's 12, 60, this would be 5, 60, and 0. So we multiplied this denominator by 15, so we multiplied the top part by 15. This one I can actually see. We multiplied the bottom part by 20, so you have to multiply the top part by 20. Again, the rule is whatever you multiply by the bottom, you have to multiply by the top. 1 times 12 is 12, so we got 12 over 180, plus 1 times 15 is 15 over 180, plus 2 times 20 is 40 over 180. And now we're ready for step 2. We got the same denominator, so we'll add or subtract the top parts. And I can do this all at once, I think. 12 plus 15 is 27, plus 40 is 67. Yeah, 67 over 180. Now, if I can think how to simplify this fraction, 67 is not divisible by 2, because the last digit is not 0, 2, 4, 6, or 8. It's not divisible by 3, because if I add these digits together, 6 plus 7 is 13. 13 is not divisible by 3. It's not divisible by 5, because the last digit has to be 0, 5. And I can start going, I don't think it's divisible by 7, 11, and so on. So that would be our answer. And let me let's see what the next problem looks like. Okay, I can fit that in, this one in here. Got 1 over x plus 2 over 3. Well, same steps. First step is get a common denominator. This one's not so easy to see, but let's take a look at the LCM of x and 3, or 3 and x. Doesn't matter the order. Okay, first step. I want to write the prime factorization of each one down. Well, 3 is 3. Not very exciting. And x is x. If this was said x squared, we would have x times x. Okay, so our LCM. We start with the 3. We're looking for the greatest number of 3's on a single line. There's 1 here, none here, so the greatest number of 3's would be 1. Then I go to the x. And when I say on any single line, we're talking about the right side of the equals. So I go to the x. We're looking for the greatest number of x's on a single line. There's none here, there's 1 here, so it'd be 1. So our LCM would be 3x. So that'd be our common denominator. And we're going to rewrite each of these fractions with that. Now we look at our first one here, and we had an x down in the denominator. Now we have a 3x. So it looks like we multiplied the bottom part by 3, so we have to multiply the top part by 3. Now our second fraction. We had a 3 down there. The 3 is still there. It just got an x next to it now. And 3 next to an x means multiplication. That means 3 times x. So we multiplied the bottom part by x. We have to multiply the top part by x. So that'd be 2 times x. Which gives us 3 over 3x plus 2x over 3x. Step 2. Since they have the same denominator, you add or subtract top parts. So we got 3 plus 2x over 3x. Typically, you put the part with the variable first. So I'll rearrange this as 2x plus 3 over 3x. And that's our answer. Let me save this page. Time for it to blow up. I'm looking at getting my son archery lessons. Okay. Just wasn't feeling very good last night, so I didn't look into it. Okay, so we got 5 over 2x plus 2/3 minus 1/6. First step. Want to get a common denominator. So let's find the LCM of 2x, 3, and 6. Well, first step. I want to do the prime factorization of each one. So we got 2x, we got 3, and we got 6. Now, if you got a mixture of numbers and variables, you just handle each of them separately. Not very exciting. Because 2 is prime, and we only got 1 x, so that's just 1 x. 3 is prime, so that's not very exciting. That's just 3. And 6 is the only one we have to do anything with, really. 6 is 2 times 3. So then our LCM. We'll start with our first prime, the 2. I'm looking for the greatest number of 2's on a single line. There's 1 here, none here, 1 here, so the greatest number of 2's is 1. Then I go to my next prime, which is the 3. I'm looking for the greatest number of 3's on a single line. None here, 1 here, 1 here, so greatest number of 3's on a single line is 1. Then I go to the x. I'm looking for the greatest number of x's on a single line. There's 1 here, none here, so it'd be 1x. So 2 times 3 is 6, and we'd have 6x. Now I'm going to rewrite each fraction with that new denominator. Now our first fraction here, it already had the x, so the x is there. Think, what did we multiply times 2 that would give us 6? Well, we multiplied the bottom part by 3, so you have to multiply the top part by 3. Now here, let's look at the numbers first. We got 3. Think, what did you multiply by 3 to get to 6? That was 2, so you have to multiply the top part by 2. But even more than that, we don't have an x down here, but now we do. So we multiplied the bottom part by x, we have to multiply the top part by x. Now over here, it already had the 6 is still there. The only new thing down here is an x. And again, that's multiplication, 6 times x. And so we multiplied the bottom part by x, we have to multiply the top part by x. Well, 5 times 3 is 15, so we got 15 over 6x. Plus, 2 times 2 is 4, so we got 4x over 6x. Minus, 1 times x is 1x over 6x. Well, step 2. Add or subtract the top parts. So we're going to have 15. Let me, oops, I don't mean that to be in red. There we go. So we're going to have 15 plus 4x minus 1x over 6x. This one has actually a couple extra twists. One of them is introducing the idea of like terms. And I wanted to introduce it here just so you've seen it before, so when we cover it later on it won't be bizarre. Like terms is where you have the same variable to the same power. So same variable, the same power. So we got 4x minus 1x. These are both x to the first power. So this 4x here and this negative 1x are like terms. Now to combine together like terms, what you do is you add or subtract the numbers that are out in front. So we got 4 minus 1, that's going to give us 3. And then the x just remains. All over 6x. There's actually a little bit more simplifying we can do on this particular problem, but I don't want to muddy the water too much at this point. So we'll just say that's our answer. And later on we'll see how we can simplify that further. I think that was the last problem. Yes, it was.